Well, good evening. Um, Yesterday I made a video on how to make a ball differential at a 30-second scale. This is the example. A fairly simple thing to build, to design in 3D print. You can build a ball differential, or you can buy a Mini Z ball differential. You need to cut the axles off because they're too long for 30-second scale, but basically this is a 30-second scale car with a Mini Z ball diff fit in it. The other half to building or converting a 30-second scale slot car to RC is the front end, where you need to have steering, you need to have a suspension, and tonight I'd like to explain what I've done to build the front end. So, to start with, this actually, my adventure into trying to design this started with kind of a little bit of a wager between me and a friend. He had just bought a 3D printer, and I was explaining to him that 3D printers were not going to be capable, not consumer grade 3D printers, uh, of printing what you'd need to build a 30-second scale slot car. And at that time, I didn't even know you needed a differential in the rear straight axle. That would have been very easy to do. But what worried me about the front end is that I thought that to make a 30-second scale car handle well, to make it drive like or close to like 10th scale cars, that you couldn't do a front suspension with poor geometry. You needed the best front end that you could design. So I felt you needed upper and lower A arms, and what worried me about that is I didn't think you could print the ball and socket joint that's required for upper and lower A arms. And so I basically explained to my friend that you couldn't do it, and he said, well, yes, you can. It was pretty simple here to just put two parts similar to this into Fusion 360 and run some tests. And on my way to proving that it could not be done, you couldn't have a small enough ball and socket in PLA plastic. It just wouldn't work. And instead of proving that it wouldn't work, after a first couple of prints, it started working. So then kind of had to go ahead and try and design the whole front suspension. So one thing just to say up front, I think many of the 24 scale cars early on, maybe still today, in fact, often they're kingpins, and the pivot, the front wheel pivots around a pivot that's outside of the wheel, where in an actual car and in the 10 scale cars, the pivot is actually within the wheel. That's, I think, the right place to put it. If you put it out here, the wheel swings such a wide arc that, for one thing, it'll interfere with the wheel well, and you lose the scale appearance of the slot cars, which is one of the big reasons for doing slot cars, is to maintain their scale appearance. So you need to get the pivot inside the wheel. And then also you need a ball and socket joint for the upper and lower A arms. So that said, this is a turnbuckle, and so there are the balls. Those are 0.116 in diameter, about. And what I found was, I was kind of right in a way. When you look at these under some magnification, they look absolutely horrible. They're not round, they're oblong. You can see the stringiness to them. They look horrible. But you file a couple of bad spots down. Basically, you're looking to get a snap action into the socket. You're looking for it to snap in. And initially, I think you're looking for it to be not particularly rotate very smoothly, but then you work it. You rotate it around, you move it up and down, and after you worked it enough, it starts being smooth. And there is absolutely no play in this. There's no play at all. It's I mean, it might as well be, you know, precision made. It's the PLA. I think it just kind of it seats against itself and settles in and makes a really good ball and socket joint. When the car falls on the floor, this doesn't come apart. Once you get it built, it's there forever and pretty durable. Now building it, I do lose some. I usually I may have to build two to get one good one. You know, and like something breaks putting it together every other time. But you know, I print extra parts, and then I just keep assembling them until I get an assembly that seats in right and works well. If I possibly had a better printer, I'm using the Ender S1 printer, or maybe I change the material, or maybe I change the design a little bit. You know, maybe I'd have every one would work. But not worth it really for me because these parts are so small, they print in minutes. It's easy to print some extra ones and just assemble them until they work. So these are the upper and lower A arms and the ball joints. On the other end, I need a pin. The pin, I again use a paper clip. I just clip a little paper clip off. The paper clip's 30 thousandths in diameter. I use that as a pin where that fits in. There's the paper clip right there. Paper clip fits right in there. And I just need an axle type joint right there. But this one's got to be a ball joint because it's got to move up and down, and it's also got to turn this way. It's got to be a ball joint. Oh, there we are. This is not a good one. So, and actually, so basically this one's barely holding. But the ones in the cars, they don't come out like that. And this one actually in a car would probably function just fine. So needs a spring. It needs a spring for the suspension. The spring I use basically, this spring kind of goes through a hole through here, through there, kind of fits up into there a little bit, and it presses down then like this, so when that thing pushes up like that, you get a spring action, and that basically is the spring. Generally, I put the springs in this bulkhead or stanchion here, and you can see how they set in there, so that when this part, the spring pushes it down like that. So that's the spring pushing down. On this one, I used a coil spring. The coil spring works well, but coil springs, if you go to buy them, and particularly like if you want an assortment, you know, fine gradations of coil springs, the companies, I don't know where to buy them, that I'm not dealing with a company that wants to deal with manufacturers and has minimum orders. Um, you can buy Mini Z springs, a little assortment of Mini Z springs, but they're $7 or $8 for a couple of springs, and these, for a few dollars, you could do hundreds of cars. Also, you can buy an assortment. This is 10 mils, but you can buy an assortment, 10, 11, 12, gradations, until you could tune the suspension without paying an arm and a leg for the springs by buying an assortment of the springs. So basically, something else to say of the front end. Let's point this out first. I hope I can show this. This wheel, when it turns, is pivoting around the socket, the ball socket, which is inside the wheel. The pivot is about right there on the wheel, not out here. It's not a kingpin. It's not that the pivot is not out there. If it were out here, the wheel would not stay within the wheel well. The pivot is like here, which is about where it is on 10th scale cars and full-size cars. So the geometry is right with this. And the upper and lower A arms mean that when the wheel lifts, it doesn't go like that. It goes straight up and down, which I think is also better than some other geometries. So I think the geometry is I'm not aware of any, well, there are very few 32nd scale cars, if any, on the market. But even the HPI RS32 did not, I don't believe, have as good a geometry as this. So I don't think there is anything out there which I think has as good a geometry as this. As well, I went to some lengths to try to form the linkages and the steering geometry so that I could turn the wheels a full 45 degrees. And the steering wouldn't lock up. What can happen is, as the wheel gets toward 45 degrees or more, these linkages become kind of like a straight line, and then when you try and turn back, they've locked up. The linkage has locked up. So it took a little bit to work it out. Where, for instance, it's just about locked up right there, but it doesn't go quite that far. Basically, I tune the radio to as far as it'll go without locking up. And because I'm using a hobby grade radio and I have fine control of both the left and the right travel, I can get the steering tuned just as far as it'll go for the tightest turn. Which, because the idea of this is to race on a tabletop, I want a very tight. I want it to be able to turn on a very small radius. So that's steering, linkage, geometry there. Spring can be done two ways, with a coil spring or with a music wire spring. But it's hard to get everything to show up. Yeah. before I forget, I do want to show the parts I used here. Um, these bearings are a little larger than what I'm using now. To fit all of this within the wheel, you want the distance from here to there to be as small as possible, and yet you want a large enough ball and socket that it holds together. So one thing you could do is you can reduce the diameter of the bearing. This bearing is 5 mil outside diameter. I went to a 3 mil outside diameter bearing. They are really little things. And I was able to just reduce this span, which I needed to do to get it into the smallest wheel. This one fits within the Chaparral wheel, but it's a little tight for the Lola T70 wheel. But when I went to the smaller bearing, then I was able to fit that into the Lola T70 wheel. And of course, there's no problem having this small. It's only a problem when it's too large. So I've kind of standardized on the smaller bearing, and they are very tiny. So here's the bearing that I've somewhat standardized on, and it is a 1 millimeter ID, 3 millimeter OD, and then 1 millimeter thick bearing. You can use like a 39 thousandths diameter drill bit to make the axle, or you can buy a 1 millimeter rod to make the axle for the car. Then I used 10 mil piano wire, and this is enough to do a huge number of cars, maybe 100. So the all-in price to buy the purchase parts is $4 and $7, so $11, and you have all the purchase parts you need to build. Well, this would be for like 10, so you could build a couple of cars. Or I actually, when I bought these parts, I spent more like $35, and I bought 100 of the little bearings. And then I bought just a full set of music wire. This gives me the ability, if I wanted to, I could tune the suspension by going to a different wire diameter. And also I used these wires when I did my 35th scale tank for the suspension in the tank. It was, I forget what wire size I went with. It was something more than 10 mils though. Anyway, I just wanted to have this assortment of wires for any future projects. Maybe something else to say about this. I wanted with the car to be able to put a full interior in, and if possible with no compromises. I wanted the driver to fit in. I didn't want to cut off the driver's feet or legs. So his feet, the driver's feet, go all the way out to like about here. And the car interior actually sits above all of this. That was part of the front end design, was to try and make everything small enough that I could get a full interior, that I could preserve the full interior of the slot car. I used the Blade Nano servo as part of keeping the profile low enough. Also, many of the cars that I'm modeling, the hood is pretty low and it slopes down pretty quickly. So that came into, factored in as well. If I didn't require preserving the interior, I could have used a more conventional rotary type servo in the back here, and basically, if I and for the price of not caring about um, retaining the interior details of the car. So hopefully, I've shown this in enough detail. Maybe one thing to say about this is way more suspension travel that you need. You may not need any suspension travel, but I wanted it to be there um, because maybe you do. But with 32nd scale car on a smooth surface, relatively smooth surface, just the barest minimum would be all that would be required in suspension travel. Um, and I'm not trying here to give an exact design. I'm basically just trying to show how I went at it, and that you can do an upper and lower A arm, and you can get somewhat the same geometry that you have in a 10 scale car, and it all works. And I think designing your suspension is a good bit of the hobby. Uh, I know I spend probably more time designing than I do running the cars. I like running the cars, but the designing is really, I get into that as well. Um, okay, like one other minor thing to say here. Uh, this little red bit right here is heat shrink, and it just goes over the axle, the drill bit, the axle that I've used of the car. This wheel would pull off pretty easily, but the heat shrink is enough to retain the wheel. In use, it doesn't loosen up, and you can push the heat shrink. Hold the wheel here, and just push the heat shrink all the way in. It rests against the inside race of the bearing, and therefore it can be pushed right up against the bearing, and the wheels still turn free. This wheel, I can show this wheel. It came off because it doesn't have anything retaining it. I didn't have any heat shrink on it. But basically that shows just the drill bit that I used for the axle. For the actual bearings I'm using now, as I say, 1 millimeter is about 39 thousandths of an inch, and there's a drill bit that is so close to that. There's an English size drill. Don't even need a metric size drill, and it fits adequately into the 3 by 1 millimeter bearing that I'm currently using. Okay, I think that's all I have to say on the front suspension. I hope that's enough. That if somebody wants to design one, I'm hoping that somebody will find a way to improve on what I've done. Anyway, if you can, I found the rear differential is absolutely required to make the car handle well and turn the same way in both directions. The differential is required. If you can build the differential in the rear, and you can build the front suspension, you pretty much can build the car. Because the chassis comes down to just a plate. So that leaves me maybe talking about a little bit building the chassis yet to do, and what electronics I used to talk about, and then I think I'll have pretty much described all I have to say about converting a slot car to a radio controlled car. Thanks for listening.